Hey friends, welcome back to Civil Engineering Mastery. Today, let's look into the very interesting checklist which is required for the structural engineers or a structural consultant when they are invited for a site inspection of a suspended floor which is solid, slab, and beam. This checklist is not only important for the structural engineer or a structural consultant, it is also very important for the site engineer or site supervisor to make sure that all the structural systems are installed properly before concreting. So, if any flaws are there, they can rectify it immediately if they follow this kind of checklist before they are good to go for concrete. So in this video, let's discuss all the points in the checklist with examples. So without further delay, let's begin now. The first point is we have to check the structural system, that is the framing layout of the structure. Support system of the structure is installed properly on the site as per the drawing. We are going to check the beam and slab. So what are all the supporting system we have to check over here? We are going to check the beam support and the slab support. So beams are supported with the columns, so we have to make sure that all the beams are properly connected to the supporting column. Similarly, all the slabs are properly connected to the supporting beams. So in this way, you have to check the supporting system as per the structural layout in the site. We have to make sure that none of the structural elements are missing. As per the structural drawing, all the structural elements should be present at the site. And also we have to check the structural member size. For example, we are checking the floor. So in that we have to check the size of the beam and slab. So thickness of the beam and the thickness of the slab we have to check. We are not supposed to make an eye judgment. We have to use the tape and then measure the size of the beam, that is width and depth of the beam, as well as the thickness of the slab needs to be checked properly. First, let's look into the reinforcement for slab. So before checking the reinforcement, first point is we have to check the cover block to the reinforcement. So the cover block for the slab as per the IS code is 15 mm. So that needs to be provided. We have to check the cover blocks are installed everywhere in the site as per the notes given in the drawing. And after that, we need to verify the rebar spacing for slab is adequate. That means we have to check the spacing of the bars. Here we have the spacing as 8 inches. This needs to be verified. We are not supposed to provide too congested reinforcement spacing. If that is the case, if we require such a small spacing of the rebar, we need to increase the dia of the rebar to 10 mm. For example, if we are providing 8 mm bar at 4 inch center to center, in that case it will be very congested to install the reinforcement at site. So we have to go with the higher dia of bar. Instead of 8 mm at 4 inch center to center, we can go with 10 mm bar at 8 inch center to center. And also we have to check the bottom top and top bottom and top reinforcements are placed in the correct directions. That means when you take the slab, you will be providing the reinforcement in both the directions if it is a two-way slab. For example, let's take this slab. So in this slab, the shorter direction reinforcement needs to be placed at the bottom. That means at the bottom of the slab, this is the outermost layer, and then on the top this bar will come. That means this is bottom and this is bottom top. And similarly, when you go to the top reinforcement, so here we have the bottom reinforcement detail and top reinforcement detail separately. So when you take the top reinforcement detail, these are the main bars. So this needs to be provided at the top layer of the slab, and then below this there will be a distribution bar. So this is the top bar, and top bottom bars will be the distribution bars. Next point is beam reinforcement prescribed in the drawing matches the site installation. So as we did For the slab, similarly, we have to check the cover blocks for beams as well. So for beams, we have to provide the cover block as 25 mm. So that needs to be verified in the first stage, and then we have to check the link spacing, that is the stirrup spacing for the beams matches the drawing. So as per the drawing, the same spacing needs to be given in the site. This we have to measure and check whether it is provided properly or not. And then we need to verify the reinforcement is not congested, which can cause the honeycombing. So we have to check the reinforcement, the layer of reinforcement in beams are not congested. And also we have to check the location of reinforcement labs and lab length, ensuring that they occur in the compression zones. So that needs to be checked properly, the lab length location and the lab length. So these are all the checks needs to be done in the beam reinforcement. The next point is we have to verify the proper supporting system, that is the props. Verify all the props and other temporary supports are properly installed to avoid formwork failure. This is very important. If any one prop is in loose condition or not properly installed, that may lead to the collapse of the entire formwork. So make sure that the entire formwork is installed properly to avoid the formwork failure. Before signing off the concrete, we have to remove the foreign materials from the formwork and then confirm the alignment of vertical and horizontal elements. The contractor or the site engineer has to provide the test results for all the materials used, including concrete grade and steel tensile strength test. Once we check all these points at site, we are good to go for the concreting. So friends, I hope you all like this video. Please do comment in the comment box if you have any queries, and also don't forget to subscribe the channel for more videos. Thank you for watching.